Thank you very much to everyone who is here this morning. Thank you to SEB for bestowing to me this honor. I still call it a surprise, a beautiful surprise when Dr. George emailed me and the months that followed before he emailed me again and told me that I was the recipient. And I'm truly, truly honored. And so as you'll see today, I'll talk about beyond the lab, the quest to make science accessible to the public and pass it on to the next generation. And this is just truly an honor because I believe we were chosen because we are working towards passing it on, and we are the next incoming scientists who are bound to do amazing things. So thank you very much. So we all know of our shared global challenges, which are real. They affect a big population, mostly in the developing world, which I happen to come from, originally from Kenya. First being the changing climate and public health issues. We're just coming from Ebola, and we have other diseases that keep emerging and are bound to emerge in the future. Hunger and food insecurity, which is a topic that's very dear to me, and part of the reason why I do what I do. Feeding our growing population. As you know, we are currently at 7 billion. We're expected to project to by 2050 will be 9 billion. We have to find food. We have to eat. Water scarcity issues. For those of us who live in the developing world, in California too, water is a big issue. And degraded soils. I'm a scientist, I'm an entomologist, and even to feed ourselves, we must grow the food, and a lot of our soils are degraded. And these are just some of the few challenges that we, the humanity, face. And the good news is that we, the scientists, actually are actively working every day to provide these solutions. Yesterday and throughout today, I've started to beautiful talks where solutions, I can see emerging solutions from our science. And so science truly has been providing answers and will continue to provide answers that are needed to tackle these shared global challenges. Science generates solutions, and my own research, so I'm a scientist to begin with, has also been part of effort trying to help address the challenges that we face. And my research for the last 8 years has been on beneficial soil microbes and how they interact with plants and then later to impact insects. But I've also worked on different systems. I've worked with ants, I've worked with stored product insects. I've truly been privileged to work in a range of systems. But what I'm truly proud of and passionate is the work that I've done with beneficial soil microbes, because I believe it has the opportunity to provide solutions to some of the challenges that I talked about. It has the opportunity to help us grow food and grow it sustainably. And also it has the possibility to help us deal with the degraded soils, as well as controlling insect pests, which we know cause 50% of crop losses around the world. So my work on beneficial soil microbes began in 2008 in Auburn, and we chose a tritrophic system based on, we used cotton to begin with, but we later expanded to other crops. And our herbivores was the beet armyworm and the tobacco badworm, and we had their natural enemies, so it was a truly tritrophic system. So when I got to Auburn, a lot had been done about beneficial soil microbes, but nobody had really looked at the chemistry, if interactions of plant with beneficial microbes changes the chemistry of plants. And for those of us, we know that volatiles truly are important. They mediate a lot of plant and insect interactions. Insects use volatiles to locate their host. natural enemies use volatiles. So this work had not been done. So I was so excited, and I remember just telling my professors how excited I was. And if we have this result, what are the consequences, both to the plant, to the herbivore, and to the natural enemies? And are there any other benefits? As you will see, I'm probably a scientist that's interested all the time in applied sciences. I believe it's good to generate science, it's good to generate the results, but we have real problems that everyday person faces, and we must provide answers to that. So in my lab, I was privileged to work with a professor Klepper, who is a renowned scientist, the father of the field, and we had over 1,000 different strains of these beneficial microbes. So my work was to, first of all, treat seeds of cotton plant with PGPR, and then we would grow the plants in the greenhouse, and followed by a lot of collection of volatiles and identification, and then finally behavior to see how this change chemistry would impact. So this pioneering study actually gave me tremendous result. I remember the first time I had my results, like, wow, truly it's different, and I couldn't believe it, and I remember my professors didn't believe it, and we had to do and ask different students to do it so that we are certain for truly that beneficial soil microbes were changing the chemistry, and this was eventually impacting insects. And as a result, as I say, this was a very pioneering study. And instead of publishing it in Science, we chose to pursue, the companies were right at us, and we filed 3 US patents, and had a lot of just companies just coming to us and calling us every day, like, can we follow up your results, and so that we can get products. And eventually, yeah, it was truly 4 years. For 4 years, we had great projects and big projects. But the good thing about it is that it really opened up many research questions. We had a lab that was born out of this work. We had several PhD students, and we have postdocs. And for me, I was privileged to also be inducted in the National Academy of Inventors, so I humbly call myself an inventor. And so it was truly a privilege. And to those of you PhD students, you never know what your research is going to produce at the end of the day. But above all, the research that went on to be done out of my work proved that there was other benefits apart from the chemistry. We realized that PGPR, the beneficial soil microbes, were changing the root growth. And we believe that in our plant that has better root growth probably is going to make and be good when periods of changing water. And we also realized that not only the roots were bigger, the plants were bigger, so we were improving our crop productivity. And we also further realized that actually the research was also, the insects were being affected. So if you're an insect and you're feeding on this PGPR or beneficial soil microbes treating plant, they were not doing well. And so that's why you see the industry was really wanting to develop products out of this. We also found out that this work, also the beneficial soil microbes are helping plants to tolerate stress, and this was my work with cotton and corn. After 5 days of no water, plants that were treated with the microbes were still doing well, and this was also a good result. But I would say, with all these patents, with all these good results, I was still feeling sad because I knew that that science only mattered to me, to my scientific community when I talked about it, to the industry, but it was not truly made aware to the public. Nobody out there was aware that beneficial soil microbes could be our allies in agriculture. They can help. And so this is a problem with many of us scientists. We tend to just have those beautiful science discoveries locked in journals. We don't share them. And that's very true. I mean, we have beautiful studies. Every day I read papers from Science to Nature, and they're amazing discoveries that every one of us is doing. But the problem is they're locked up in the journals. And remember, as I said, I believe in applied sciences. And in just one day, we, the scientists, produced roughly 2.5 million papers. And the sad part is, while we are the ones who are reading them, the public is not reading them. The truth is that only 10 people can read an entire manuscript. And I know it takes time. I've done science, and I've sometimes slept in the lab. And when you think about the effort that you put in your work, for me, I think it's sad that at the end of the day, when it's out in the journal, nobody reads it. So it just doesn't really make me happy. But I know the reasons as to why. I keep on coming back that the first thing, I'm a passionate science. And I know our university system, especially probably in the US, we are not rewarded for taking that extra step. All they care, and I'm soon going to get into the assistant professor, going through the tenure rank. I know that I may have to cut down on my science outreach because I have to give the publications. I have to write proposals. I have to get funded. And this is what is going to be used to judge me as a scientist, but not what I do. I also know that we are truly not training our scientists about communicating. We don't know, but we are well trained about writing our hypotheses and writing our manuscripts. But our university systems are not doing a good job making sure that we, the scientists who do the work, can be able to share our work with the public. And then, as I say, there are no real incentives. And I've participated in it, but one of the incentives, I would say that I'm a president's medalist, so that's one of the rewards that I appreciate that. But I know to many of us who take that extra step, there are no real rewards. But once again, as I say, the challenges we face are dire, and I come from Kenya. I go to Kenya regularly, and I've seen firsthand the challenges. I've seen my neighbors face hunger. I faced it when I was growing up. It was not new to me. We would stay for days without food. And so I know that the public need this solution. And of course, we know if we don't share our work, the public gets ignorant. And for those of us who live in the United States, you know what's going on. Nobody is accepting that climate change is real. And so we don't have to wait until we have to do much for science. No, we have to actively communicate our work. And I also remember there was one, for those of us who are in Twitter, remember that we had to have this tagline, actual living scientist, because a study in the United States showed that most Americans could not name a living scientist. I couldn't find that, it was hard to believe. So we shouldn't wait for that. So I believe that as scientists, we must have the sense of urgency to be able to communicate our work. It is important. And so with all my training, with all my patents, with all my work, luckily enough, in 2015, I was nominated and finally given the opportunity to become an Aspen Institute Food Security Fellow. And this is where I got my aha moment. This is where I was trained about how to write and share about my own work. And I was mainly taught about writing opinion pieces, and which I'm grateful. And since my training in 2015, I would say that I've written, I write almost every month. I've written over 70 pieces, and I've been able to publish them to the places where the public is, where public is reading their media. I've been lucky to publish my work some in CNN, in Los Angeles Times, in Time Magazine, and in many other outlets, basically finding the public where they are and getting them to know the work that I'm doing. And so for those of you that are just interested about OpEds, basically it's unlike a manuscript, I would say, where we have to write 20 pages First of all, it's just 900 words. I find that very easy. But you have to have core argument, and you also have to connect your research, your findings, to the things that are happening every day. And as I said, for me, I'm lucky because my work neatly ties to climate change, to soil degradation, and so I can easily connect the dots. So for those of you who are interested in learning how, and we'll have a science communication workshop, you're welcome to attend. We'll share about how you can go about doing this. Then you also have to find the story in your research. As I said, the public doesn't take boring stuff. So you have to truly be able to be creative. And you also have to, of course, maintain the science and the scientist in you. We believe in data and evidence. And so you cannot just argue without strong evidence, and which I think for me as a scientist is easy because I have data that is consistent, data that has been done by other people too. But also, as I said, one of the elements that's different is you have to find something that's in the news. So every day I normally look at the headlines, and I'm always finding ways to connect anything that's happening to my research. Just recently, I was able to connect World Cup with my research. So you have to just keep getting creative. And then finally, you have to have a call of action. You know, why are you asking the public to read your work? What do you really want? What do you want the public to take away? Are you calling for more funding? But as I said, keep it short, and let's avoid the scientific jargon. We all know about it. It's what keeps this public away from reading our work. And I would say OpEds are not the only way to publicize your work. We have newspaper articles, Twitter, Facebook, blogs, university press releases, technical briefs, and local radio. And I say there are two benefits in communicating our work. First of all, you reach the public. Secondly, you facilitate the utilization of your own research. As I said, I'm happy that my research right now is being used by the industry. They're coming up with products, and these products will end up at the farmers. It will help the farmers. You also increase citation to your own research, by the way. It's kind of you're publicizing yourself, you're publicizing your research. You're also drawing attention to funders, to your future employers. I would say that probably why I'm a President's Medallist, because I'm out there. And that's probably how they found me. So that's another perk. But you also help changing policies. You help drumming out for funding. And I'll show that some of the things I've written have actually ended up truly creating this impact that I'm talking about. So I'm not just talking of things that I haven't experienced. And then there's joy in growing as an expert in your field that can be consulted. I know that I do pick calls from CNN, from local news. They're asking questions because they know I'm out there and I'm an expert in my own field. And I would like just to share one of my pieces that I'm proud about. It was Soil Science for a Hungry Planet. And when it was published, I'll say up to now it has appeared in almost like 36 different publications and in 28 different countries: Japan, Saudi Arabia, Africa. I mean, I've had people call me from different countries, and I'm like, wow, I read your piece. So there's real impact that comes around with. And I've had companies ask, what can we do? How can we develop products from beneficial soil microbes? You can also help change policy. The people that read news at the moment, we have insect invasion in Africa, the fall armyworm. And I picked up, because I'm an entomologist, I wrote so many things about it. And one day, I was surprised to have a call from USAID, one person from USAID, and they asked me to write a technical brief about the area. This brief has been shared in all the countries where USAID is, and it's helping change the policies, change things, how things are run by the government. So there's real impact to what can happen when you decide to take that extra step and share your work. But as I said, I come from Kenya, and besides actively just doing science and sharing my work, I believe in mentoring. Because I believe the future of science, so important to our world, depends on how our senior scientists pass it on to us, and how we junior scientists pass on to the PhD and to the upcoming generation. So I believe in mentoring, and I serve as a mentor. And probably for me, why I do it is because I grew up in a village, and I grew up with no societal role models, nobody to truly guide me. And when I graduated, I became the first girl to get a PhD, and I'd never seen a lab, never experienced science. I always say, I'm glad science just found me. But we cannot afford to lose passionate and talent out there just because opportunity is not available. So for me, it's a dear thing. I do mentoring with a whole heart because I know it has taken true mentors who just saw the passion in me, saw that bright star scientist that was just passionate and curious about asking why. And they held me, and they helped me move along. I always say, I remember my first time when I did my results doing my master's. What I expected didn't happen, and I went to my advisor crying, and I was like, my hypothesis didn't work. And he said, Esther, calm down. This is how science works. Sometimes what you hypothesize may not happen, but this is still a result. And so because my mentors were so instrumental in my life, I believe in mentoring. And so I have served as a mentor to several students. I'll say I don't even keep a count. My Facebook is like a buzz because every day, every morning, every evening, I'm consulting with students from around the world. I've served for President Obama, Young African Leader Initiative, for President Clinton's Clinton Global University Initiative. I love just interacting with students, and some of my two students when I worked at Auburn, Larissa, who is now serving as a scientist in a Birmingham zoo. She loved animals. We couldn't keep her away from the birds, even though I tried to impact her and get her to love insects, but she's still a scientist. Ryan, who is holding corn. When she came to our lab, she didn't believe in science. And I saw her just grow up into be this amazing scientist. Today, she's pursuing a PhD in George Washington University. So I'm proud of all the students that I keep working with, and I'll keep mentoring. I will never tire. But finally, when I'm not still working on mentoring, research, and sharing my work, I love to bring real change to my community. And in 2012, I started a school in Kenya. And I always say, use what you have. And this is when we began in 2012 with basically just one building. Today we've grown. It's a true school. And I hope one day I will actually be bringing students here to SCB to attend the meeting from our school. But as you see, I'm a dreamer. I believe in big things. And this is a school that I hope to have in the near future. And I'm actively working to create that. And as I said, I'll never tire. And I must not forget about the science, because I'm a passionate and love science. And when I got married, I decided to give up on my wedding gifts to be able to build a science lab in my compound. I'm still working on that. I haven't achieved that dream, and I'm working on it. But besides that, I work with farmers. I make sure that they're getting the knowledge that is there. And finally, I say that truly doing what I passionately love, both in the lab, outreach, has allowed me to truly get rewarded. There's a lot of things that have happened. So there's good things when you step out and you become non-traditional. And I would say that, yes, I'm very untraditional, and my advisors finally just said, you know what, Esther, be what you want to be. But I've seen the perks of being what I want to be. I would like to acknowledge many, many mentors, and they couldn't fit in this slide. I truly have been blessed to have many, many, many mentors who hold my hand every day. And finally, thank you once again, SCB, for bestowing this honor to me. And you can follow me up on Twitter. I believe in activism and in social media. Thank you so much.